What's that?
Yeah. All the image supposed to be one, all the person supposed to be one, all the definition supposed to be one.
You have any questions for me? Yeah.
Can you give a brief array? Okay.
I will indeed. I'll definitely talk about arrays today. Got that on the agenda. What else you got? Any other questions? What was the video tips that you were supposed to do before this? 4 steps of the compiler. Okay. All right. Well, let's actually kick it off talking about arrays. So the issue for which arrays is a nice solution is if you need several of the same kind of variable. I think a good example would be like if I needed to have a variable for each of you to store your grade point average or some random class. Without variables, I'm left with the need to create a floating point variable for each and every student who I want to keep track of. And this is particularly problematic if you think of things like passing them to functions. So if I wanted to calculate an average, then in a class of 60, I would have a function that took 60 input parameters. And that, of course, is prone to error and would look like a huge nightmare. So that's the premise under which arrays become helpful. And the syntax for it is you create your variable the way you normally would, except you use square braces and you indicate how many of them that you would like. So if I wanted, I'm actually going to use a relatively small number just to ease the presentation. But this is indicating that declare, or if you want to use the word create, I think declare is what you'll normally hear, but create 5 floating point variables. And then the thing to keep in mind is that with arrays, I guess I'll put the comment down here, counting always starts at 0. So I can go ahead and say float, or excuse me, not float, GPA 0 is equal to 3.5. GPA 1 is equal to 4.0, and you could go until you do, the last one would be GPA sub 4 is equal to, whoops. I think what I'll do is I'll leave this commented out. I think this is good for just driving home that the counting starts at 0. But if I was to say ask the user and fill these in, I might do something like this for int I equals 0, I is less than 5, plus plus I, cout, let's do this, please enter GPA for student, and then since we as humans like to start our counting with 1, I'll say I plus 1. I guess I won't put an end line. Maybe I'll put a colon and a space. And then I can cin, and I'm going to go into GPA csci. So let me go ahead and test my code at this point.
You're missing a semicolon.
I am. Okay, thank you. Let me get this all the way on the screen here. Let me see. I'm going to put this so that it is visually a little bit nicer. I'll just put that on its own line. Alright, so that's the code. I compile it. Let me change my prompt here so that I have more typing real estate on the G++ and C++11. Okay. So let's do something with that. Let's actually write a function that'll calculate the average. Actually, before I do that, let me actually, since you're calculating the average in the lab, let me instead find the largest of all these numbers. So let me bring this front and center again. So I'm going to write a function called, what I'm going to do is I'm going to return the largest of all the numbers given to me. So float is what it's going to give back. That's the kind of thing. I'll call this find largest GPA. And then there are a couple ways for me to specify this. Let me stop with a peculiarity about arrays in this language, is that there is nothing in the array itself that tells us how many of them there are. Now you and I are writing this program, and we know right here that there are 5 of them. But I have to keep that in mind. I have to know to put the 5 here. And when I get to this function, I think I want to make this function general in that not only can I pass in an array 5 GPAs, but I could pass in an array of 60 GPAs, and this function would still work. So what I have to do is I have to pass in information on how many items are in the array. So the way I would do that is I'd say number of them. Note that this is empty here. So this is indicating that we're going to take some array. We don't know how many items are in it. You're going to see a different kind of nomenclature for this bit here that is you see equally frequently. And we haven't. And this is, if I was to read this properly, I'd say that some array is a float pointer or a pointer to floating point variables. We haven't talked about pointers yet. Probably to the extent we talk about them, it'd be at pretty much at the end of the semester. But these two notations are synonymous. So if you see one or the other, just at this point in time, just think that some array, this variable is an array, whether you see the asterisk or whether you see the square braces following. Also, remember that the spacing is really liberal in the language, so sometimes you'll see the asterisk over here. That's the same thing. Sometimes you won't see any. Actually, you won't see that as frequently, but that's the same thing as well. So as far as the language is concerned, the spacing has no significance. I'll leave this here commented out just to remind you that that's a valid notation. So, let's go ahead and how do we figure out the largest? Well, let's look at a simpler question first, because it'll bring us to where we want to go. Help me write an algorithm that's going to print out each of these. So that isn't the purpose of this function, but let's make that the purpose for the moment. How can I print out all of them? All of my GPAs?
Go through the length of the array and then just print out the value.
Okay, so using a for loop. And we stop, or we keep going as long as I is less than number of them. And then we just do something like sum array sub I. Now, again, I indicated, let me change this. So, again, I'm abusing this in that we aren't finding the largest GPA yet. In this printing them out, I'm not going to return anything, so I changed this temporarily to void. So let me just call that function just so we can see it in action. What did I call it? Find largest GPA. So I say find largest GPA, and I will pass in GPA, and I'll pass in 5. Let's give it a go. Compile it, run it. 3.5, 4. Oops. I'm gonna stop right here and do a technique that I use in the lab. So I'm doing this program over and over again, and each time I'm entering in 5 numbers. It gets a bit tiring, so I can use a little bit of a trick that the Linux shell allows us to use. Let me see. Let me copy this, and I'm just going to call this input data.text. I'll paste this in, and let's see. So what I do is in this file I just put in the information that I would type into my program, which is I'd type 3.5, then I'd hit the enter key, and then I'd enter 4.0, and then I'd hit the enter key, right? So I go ahead and write that out. Now when I run my program, rather than me having to type everything in again, I can say, let me clear the screen, I can say a.out, and if I do that, then my program, in this case a.out, thinks it's getting the information from the keyboard, but the shell, which means the shell's just this thing that takes our input and interprets them, right? If I do this, then it knows to run the ls program and so forth. This less than will cause the bash shell to fool a.out, and even though it thinks it's getting it from cin, getting it from the keyboard, it is in fact getting its input from this file. So that's why I had to ensure that the keystrokes I would normally type in to my program are the same as the keystrokes I enter into input data.text. So I say a.out less than, and I've separated all this by spaces. If I wanted to, I could get rid of all the spaces. Most often you see it this way, but I guess for our own visual purposes I'll do that. This looks a little bit different, right? This is still prompting, but then rather than me typing it in, it's getting it from the file. And since it's getting it from the file, there's nothing visual to see on the screen. So note that when I run it this way, where I have to type it in, the reason for student 2 appears on the next line is because at this point I'm hitting the enter key, and it's me causing the next line of output to be the next on one down on the screen. Since it's getting this information from the file and there's nothing visual to see on the screen, all of these output statements end up just appearing on the same line. So that's what that phenomenon is. And then this then is that function running, where it looped through and printed out each of those 5. So 1.5, 2.5, 3.5, 4.5, 5.5. Right. All right. So we know the algorithm works, just going through a loop, iterating through there. Let's take a look at our program again. Now I want to find the largest one. So I want to find the largest one and return that. Anyone want to propose an algorithm for how I would find the largest of these?
Set the largest to the first GPA, and then the next one's bigger, set that to the largest.
So then you can do something like if GPA sub 1 is greater than GPA sub 0, now this is correct as far as it goes. I guess I could just use the word largest here, right?
I was going to say put it in the for loop.
Yeah, so that's of course where we want to go with this, is we don't know where to stop because we don't know how many of them there are. So best to just do this in a loop. I think this line stays the same. I do have to create this variable, and I have to give it an initial value. It would be, there's an inclination to maybe, well, we just make largest that. Now you and I both know that GPAs tend to be larger than 0, but as far as being a robust function in general, I have no idea what are in these. Like, let's just say someone was being naughty and stuck in a bunch of negative numbers, then 0 would be the largest, right? So it isn't safe for us to decide what the initial value is for largest. So the safest thing to do is just take that first item in the array, set that to largest, and then let me leave these two here to kind of model our loop, and then I'll delete it. So I would say if GPA sub I, so I could start this loop at 1 since I already set this to 0, but it doesn't matter. I'm lazy. I'll leave it 0. All that guarantees is the first time through it'll be false because GPA sub 0 is not going to be larger than what is GPA sub 0. But next time through it'll be good. Largest equals GPA sub I. Do my GG equal G to get the indenting back. I'm missing one thing from this function. This function's complete, but it's there. I should say it's all correct. It's incomplete, though. What am I missing? The hint is on line 6, actually. You got to return a float, right? That's our promise to the compiler that we're going to return something back. So return largest. That's the whole purpose of this function. Now I can come down further down in this program, and maybe I'll say cout. Let's print a little message. The largest equals whatever that is, whatever that function gives us back. Use of undeclared identifier on line 8.
Oh, it's some array.
There you go. Very good. Some array. Let me zoom in here. Right, this right here is our variable. And again, if you haven't already figured it out, when you get two numbers here, this is the line number. That's useful information. This is not so useful. That's the column number. Column 17 is where it was detecting an error. I invariably ignore that. I'm only concerned with the line number. All right, compile it, run it. I'll do a little search for the last time I used a.out. There's that. I want the version where I get the numbers from the file. It's a little messy to look at. Whoops. the largest equals 4. And cat is just a command that spits the contents of files out to the screen. It's short for concatenate. And sure enough, 4 is the largest. It didn't print the .0, but it is the largest among those numbers. So that worked. It's ugly to look at, so let me go ahead and just do a gratuitous run here from the keyboard. And let me just get wild with the numbers. Oops. And there you go. In this case, it did a little rounding on the output. Any questions on that? So there are some limitations to arrays. And, whoops, no, I'm in a totally different program. There we go. That's what I wanted. The main limitation here is on line 20. And the problem is that I have to know how large my array is when I compile my program. There are ways to create arrays that you figure out while the program is running. It's a topic I don't want to get into right now because that gets into pointers and what's called dynamic memory. It's setting aside memory while the program is running. But even that has its limitations because let's say you're able to say while the program's running how many you want. I want 60, and it creates an array right there at runtime of 60. But then if partway through I decide that someone else adds a class and I in fact needed 61, then I've got a huge problem. What I have to do is allocate a new one of 61, and I copy the 60 over. Now I've got one extra in this new one. It's a lot of bookkeeping. It's a big hassle. The topic itself is a bit complex, involving pointers. So fortunately, the language designers did provide something in the standard library to make life easier for us, and that's called a vector. And if you want to use a vector, you have to include the header vector. And to create it, you say, I want a vector. Now, the syntax is a little bit wonky looking, but if you can get over that, you have a set of angle braces here, and you say what you want a vector of. Now, in your mind, vector should be synonymous with array. So like in the previous example, I'll stick with that. What I want is an array of, or in this case, a vector of floats. So inside of the angle braces, you put the kind of vector that you want. Then just give it a name. I'll go ahead and run with GPA since I used that in the previous example. Okay. Now, whenever let me see. Let me bring our original version up here. All right, here's main. What did I do? I created it. Please enter GPAs. Let's go ahead and repeat that. Cout, please enter. I have to change it a little bit. Please enter GPAs. Enter 0 when done. How's that? So now I don't make any decisions right now. While the program is running, the user can decide how many they want. So I'm going to use a do-while loop because I want to go through the loop at least one time, and that's kind of the unique thing that do-while loops give us, is we're guaranteed to run this loop at least one time. And I want to do this as long as they didn't enter 0. So let's say that while the, what did I entered it directly there. Let me say the current GPA does not equal 0. I want to keep doing that. So I have to create a variable called current GPA, and that is a float. And I'm just going to so now here, now I'm not doing anything. So we're not doing anything with this yet. I'm not even doing anything with this number that I'm entering, but it's a good point in time for me to compile this and make sure that it works. I'll find, whoops, there we go. All right, compile it, run it. Looking there, I think I want an end line. I'll just put a little new line character right there. 3, 4, 5, 22.2, 0, or -0, I suppose is the same thing, and it ends. All right, so that looks like it works. So now what I want to do is with each of these that I get from the user, I then want to add it to my vector. And the syntax for that is GPA So that's what that looks like. The term push back comes from visually, if you think of an array where you have a set of numbers, this would be considered the front of the array, and this would be considered the back of the array. So push back just simply means you're adding another number to the end of it. That's where that term comes from. And what do you think they call it if you want to put it here? Push front, right? So there are quite a few functions associated with this vector type, push back, push front. A real useful one is size. We'll look at that in just a moment. It tells you how many are in it. So I go ahead and push things back. I do have a bit of a bug here, though. To show that bug, let me go ahead and create a for loop for I equals 0, I is less than. I want to loop for as many times as there are items in my GPA vector. And as I said, there's a function called size, and that tells you how many are in there. I'll say I equals, and I'll print out I. And then I'll print out a comma and a space, and I guess then I'll just print out the item in the vector, so that would be, I'll put it on its own line here. GPA, and the nice thing about this is you can use this visually, it looks exactly the same as a traditional array. So I use the square braces and I just put some sort of number in there. I have more than one line that I want in the loop, so I use the curly braces. Doesn't like, what is it complaining about? Line 20.
It wants 4 into I.
Ah. So what's the bug in my program?
It keeps the I equals 4. It keeps the 0 that you entered.
Right, 0 was going to be my stop condition, right? That wasn't going to be one of my GPAs that I had in there. So I have to add a little logic here. So I just speak it out. I only want to push back current GPA if current GPA current GPA does not equal 0, then do that. Yeah? Let's give it a try. And there we go. So note again, the real advantage to the vector here is that you don't need to know how many of the items you need when you compile the program. That can all be determined while you're running the program. And vector makes it real easy. It automatically will make sure that it grows to accommodate the number of items that you put in there. Any questions on that? All right. I'll throw one more topic at you. And this one is structures. So a situation where I might want this is I want to write a function called, oh, I don't know, how about get person data, get person null data. And maybe the person has a name, fancy that, an age, a GPA. We'll just go with those three. And then I want to get these from the user, so maybe I'll say cout name. And then I'll use getLine, so if they use their full name. So it'd be getLine from cin, the name, cout, how old, how grady, not quite sure what to put there. All right, so here's the issue. I've got main down here. Maybe I want to call this function. And I want to grab all that information back. What do I return? And that's the issue. From everything we know, and nothing's changed, a function returns the kind of thing that we're giving back. So I could say string, float, int. The problem is I want to return a string and a float and an integer, right? I want to return three things, but the language only allows me to return one thing. And so we need some sort of construct to get around this limitation, and that construct does exist. That, in fact, is called a structure. The syntax for it, so I would call this a structure declaration. Here we are describing, I guess, a type. The declaration itself is simply information for the compiler so that it can help us use it correctly. The syntax is the keyword struct. We give it a name, something appropriate for what we have here. I think person makes sense. And then we have a set of curly braces. It ends in a semicolon. Inside here, we just say what comprises a person. Well, a person has a name, a person has an age, a person has a GPA. And you're not required to do this, but it actually looks kind of pretty if you line all these up like that. So again, we haven't created anything per se, meaning that lines 8 through 12 doesn't make our executable any larger. Because at this point, 8 through 12 is merely information to the compiler saying, hey compiler, I may not ever use it, but should I decide to use it, this person type that I've described, this is what a person contains, right? It's only when we actually create people that our program gets larger. This now is doable. We can say that this is going to fill in, this is going to return a person. So now, rather than creating 3 variables, I create 1 variable of type person. So I say I want to create a person, newbie, I guess. And now we have syntax that looks similar to when we were using vectors. So when we used a vector, we said we had some variable dot push back. We had this syntax where we had the name of the variable, a period, and then something else over here. That's kind of what we got going. So this is not name anymore. This is newbie's name, newbie's age, and newbie's GPA. So when you do line 16, you're literally creating enough space for 3 variables there. And we can refer to them by whatever we described a person as having. So if I say whatever dot name, then that's referring to the string, and so on and so forth for the others. And also, you're not limited. I have different types here, but I could easily do something like this, right? There's nothing wrong with having 2 strings or 30 integers or 20 floats or even an array or even a vector. You could actually put a vector inside of a person, or in my case, this person. It just depends what you need. I'll go ahead and leave the first name, last name. So this becomes first name. I'll just copy and paste those 2 lines and change first to last. Whoops. Change that to last. Change that to last. And now we return, what do we return? That's absolutely correct, newbie. The reason I asked the question is, in case someone said that, I wanted to point out that's not correct. You return variables, you don't return kinds of things, right? It's like if I said return float, well, that doesn't tell me anything. Are you returning 3.14 or 2.85? So yes, it's the actual variable that you're returning. Now on the other side, what kind of variable should my var be? Yeah. Well, how do you know it's person? Well, because by golly, this function says it returns a person. So we better have a person on the other end. So let me say person, my var equals get personal data. Now we can print it out, cout. The first name is, how about, let's actually trick it up a little bit. The full name is, and then we can say cout myvar dot first name space myvar dot last name end line. And the rest of it. Actually, let's make this sound like prose. So, first name space last name is myvar.age years old and has a GPA of myvar.gpa and a little end line at the end. Oh, so I don't like that being on a separate line, so I'll correct that eyesore. Get rid of that end line here at the end here. Let's have a go again. God, wait, what did I do wrong? I didn't recompile it. Yes. Absolutely. So even I succumb to that, but everyone at one time or another spends an hour trying to debug a bug and isn't successful because they keep forgetting to recompile. So let me find my G++ line. All right, let me go ahead and run it again. Todd Gibson. How many people think I'm older than 50 by show of hands? How many people think I'm older than 30? Let's make sure everyone knows. Hey, not everyone's raising their hand. All right. How many people think that I'm older than 55? Who is that? No, I'm 53. We won't change that at all. And that is all there. Once I zoom in, you can see that's all in one line. All right. Any questions? Yes?
What's the, can you explain the purpose of the pointer again?
For the arrays?
Yeah.
So you're talking about this version here?
Yeah.
All right. Yes. So let me see. I don't want to break out my drawing tablet. So let me see if I can do this like this. When you say float FL sub 5, what you're setting aside is enough room in memory for 4 floating point numbers. And in my example here, on a 64-bit machine, a float's probably 8 bytes. I've only set aside 4. So this is byte 100, meaning that one there is byte 100. That would make this byte 104, this byte 108, and so forth. So this is what actually, and I just put spaces here to make it visually easier to parse. Obviously, one byte follows another. Also, I just chose the number 100 because that's easy and small. It's going to be, the actual number here would be something like, literally something like that, right? So all it is there's no way getting around it. Obviously, it doesn't matter, arrays even, if I say character CH, somewhere in the machine, there has to be a byte that's set aside for that character. That's all I'm saying, right? So by virtue of me creating, oh, and I said 5 of these. All right, there we go, 4 of these. There has to be enough room set aside for 4 of these. And in fact, it is set aside, just as you see here. When I name the variable unadorned, meaning I just say this, then the question is, what is actually given to me? And what is actually given to me is the address in the computer where these 4 floats begins. In this case, in this example, 100 is given back. So to directly answer the question, and again, this is not something that I'm going to be testing you on, but what this asterisk means when I called it a float pointer, that just means what address in memory does some array begin at. That's all that means. And this actually is visually, makes a lot more sense to us, but this actually means the exact same thing. So the compiler actually translates this version into this version here. what I would do, I think this is easier on the eyes. I'd just go with this and roll with it. Okay. Any other questions? All right, we'll see you in lab.